A signal just arrived from the slopes of Mount Rainier. It was not a tremor. It was not an avalanche. It was the sound of the mountain moving. At 3:47 a.m. this morning, a network of acoustic monitors buried in the volcanic soil detected a low-frequency rumble that lasted for 11 minutes. A vibration consistent with one thing: a massive internal failure of rock and ice. The United States Geological Survey now estimates a volume of 160 million cubic meters of material on the Puyallup, and carbon glaciers has become measurably unstable. That is not a forecast. That is not a geological model running a worst-case scenario. That is the documented reality transmitted from the mountain itself, right now as you are watching this. The ground on the western flank of the volcano is deforming, moving, and here is the part nobody is talking about in the public alerts. The collapse itself is not the real danger. The real danger is what a collapse of that magnitude would unleash. A force of nature that can travel at 60 miles per hour, engulf a town in minutes, and is aimed directly at over 150,000 people. I want to know your thoughts on this from the start. Tell me in the comments, have you ever lived near something you knew was a threat? A fault line? A floodplain? A sleeping giant like this? Let's begin. Before we go any further, a moment of straight talk. We see the numbers. An enormous number of people watch our reports, find them valuable, but forget to subscribe. Our ability to fund these deep dive investigations depends entirely on your support. If you believe in understanding the hidden forces shaping our world, you need to subscribe right now. It is the single most important way to ensure you don't miss what we uncover next. It's an emergency for our channel to grow to keep making these. Click subscribe. Seriously, we have a lot to get through. The word scientists use for this threat is lahar. It sounds technical. It sounds distant. It is not. A lahar is wet concrete. A lahar is a river of mud, rock, and ice moving with the speed and consistency of a freight train. Imagine a flow of material so dense it can carry house-sized boulders for miles. A wave of earth that does not flow around obstacles. It removes them. Erases them. This is the weapon Mount Rainier has been building for centuries. And the 160 million cubic meter section of debris that is now unstable is the trigger. This is not a hypothetical threat. It is the defining characteristic of this specific volcano. Because unlike Mount St. Helens, the primary danger from Rainier is not an explosive eruption sending ash into the sky. It is water. Mount Rainier holds more glacial ice than all other Cascade volcanoes combined. Over 1 cubic mile of frozen water clings to its slopes. That ice is a reservoir of potential energy. A battery. When the mountain heats up, when it shifts, when it simply collapses under its own weight, that ice and snow can melt instantaneously. It mixes with the notoriously weak, chemically altered volcanic rock of the mountain itself and begins to move. Not slowly. Immediately, the journey starts at 14,000 feet. The lahar pours into the river valleys that radiate from the volcano like spokes on a wheel. The Puyallup. The Carbon. The Nisqually. These are not just riverbeds. They are channels. They are barrels of a gun, and they are all pointed directly at cities and towns built on the deposits of previous lahars. Ancient mudflows that geologists can read like a history book. A history book that is now repeating a chapter. The USGS lahar warning system is what detected this morning's event. It is a network of acoustic flow monitors, or AFMs. Essentially, they are microphones buried in the ground, listening for the deep, low-frequency rumble of a debris flow, the signature sound of a lahar starting its journey downhill. When multiple AFMs trigger in sequence, moving down a river valley, the system knows a lahar is in motion. It automatically sends alerts to emergency managers. Sirens are activated. The evacuation is supposed to begin. That system worked this morning. It identified a precursor event. a geological whisper before the scream. But the question that haunts every scientist at the Cascades Volcano Observatory is this: will the warning be enough? From the moment the sirens sound in the upper valley town of Ording, residents will have approximately 40 minutes to get to high ground before the lahar arrives. 40 minutes. We've just scratched the surface of how precarious this situation is. I want to know your opinion on this. Is it responsible to allow communities to grow in a place with a 40-minute evacuation window from a threat this certain? Let me know your thoughts in the comments below. To understand what 40 minutes really means, you have to look at what happened in Colombia on November 13th, 1985. There, a different ice-capped volcano named Nevado del Ruiz woke up. It was not a massive eruption. By volcanic standards, it was small, a modest puff of ash and hot gas from the summit crater. But it was enough. The hot material melted a fraction of the volcano's summit glaciers. That water mixed with loose rock and soil funneled into the Lagunitas River Valley and began its descent. The town of Armero sat 45 miles away. Its 29,000 residents had been given warnings. Scientists had produced hazard maps months earlier, showing the town was built directly on top of deposits from an old lahar that occurred in 1845. They knew the risk was real. They had heard reports that the volcano was restless. But that night, a storm was raging. The eruption was small, barely visible from the town. The warnings were confusing. Some officials told residents to stay in their homes. At 11:30 p.m., the lahar arrived. It was a wave of mud and debris 100 feet high, moving at 30 miles per hour. It hit Armero and did not slow down. It buried the town in seconds. An estimated 23,000 people were killed. Gone, the survivors described a sound like monstrous locomotives, a noise that consumed everything, followed by a wave that felt like the end of the world. The parallels to Mount Rainier are not subtle. They are exact. An ice-capped volcano, a known, mapped hazard zone, and communities sitting directly in the path of destruction. The lahar that destroyed Armero contained about 60 million cubic meters of material. The unstable section on Mount Rainier right now is estimated at 160 million cubic meters, nearly 3 times the size. The warning for Armero came in the form of reports and confusing messages. The people in Ording, Puyallup, and Sumner will get a siren. But the fundamental physics are identical. Carolyn Dreger, a hydrologist with the USGS, has spent her career trying to make people understand this threat. She speaks about Armero not as a distant tragedy, but as a preview, a dress rehearsal for what Rainier can do. Her work focuses on translating the geological certainty into human understanding. She created an exhibit that shows a jar of dry rock and a jar of lahar mud side by side. One is a collection of stones. The other is a solid, immovable mass. That is the transformation that happens on the mountain. And that is the substance that will arrive in the valley. The towns in the Puyallup River Valley have a complicated relationship with the mountain they call Tahoma. It is a source of beauty, of identity, of recreation. It is also a source of existential dread. Ording is the town at ground zero. Population 9,000. It sits squarely on the deposits of the electron mudflow, a massive lahar that swept down the valley 500 years ago. Geologists know this happened. The town is built on the evidence. Every schoolchild in Ording practices the lahar evacuation drill. They call it the lahar walk. The siren sounds, and they walk. Uphill, they have routes mapped on the sidewalks, blue lines pointing the way to safety. They practice it several times a year, walking, not running, to a series of terraces carved into the hillsides above the town. It is an extraordinary piece of social engineering, an entire community rehearsing its own survival. But here is the brutal math. The drills are done during the day, in good weather, with organized teachers leading the way. A real lahar could happen at 3 a.m. It could happen during a winter storm. It could happen when the roads are already jammed with traffic from a Seahawks game. 40 minutes. That is the entire window, from siren to impact. And that assumes the system works perfectly. That assumes everyone hears the siren, understands what it means, and moves immediately. Panic, confusion, delay. None of these are factored into that 40-minute best-case scenario. If you know anyone who lives in the Pacific Northwest, anyone who thinks of Mount Rainier as just a pretty picture on a license plate, share this video. It could be the most important thing they see today. It might seem alarmist, but the geologists who study this mountain are alarmed. And if you're getting value from this deep analysis, please take a second and hit the like button. It tells our team to make more reports just like this. The problem is not just Orting. The Lahar does not stop there. It continues downstream. Puyallup, Sumner, Fife, Algona, Pacific, the port of Tacoma. Each town is a little farther away, giving residents a little more time. But the Lahar itself spreads out, covering a wider area. The entire Puyallup River Valley floor is a designated hazard zone. Over 150,000 people live there. Another 300,000 people work there every day. It contains critical infrastructure. I-5, the main north-south artery of the West Coast. The Port of Tacoma, one of the largest container ports in North America. Railroad lines. Power grids. All of it sits on land that was formed by the very process that now threatens to bury it. This is the central crisis. Development followed the flat, fertile land of the river valley. The same land that offers a perfect, unobstructed path for a high-speed debris flow. Humans built their world on the one place the mountain is guaranteed to reclaim. It is a geological certainty. The Osceola mudflow, which occurred about 5,600 years ago, was one of the largest in Rainier's history. It was a cataclysm. It buried an area of over 200 square miles, reaching all the way to Puget Sound. The ground that cities like Enumclaw and Buckley are built on is the remnant of that single event. Geologists are not debating if another Osceola-scale Lahar will happen. They are debating on what timescale. Centuries? Millennia? Or could a smaller, but still catastrophic, Lahar be triggered by something else entirely? And this is the other fact that is often missed. An eruption is not required. The mountain is fundamentally unstable. It is a pile of loose, weak rock held together by the cold. Much of the volcanic edifice has been chemically altered by hot acidic fluids from the magma system deep below. This process, called hydrothermal alteration, turns hard volcanic rock into soft, weak clay. It is like a cancer eating the mountain from the inside out. Large sections of the upper mountain are essentially rotten. All that is required is a trigger. A small earthquake. A period of heavy rainfall that saturates the ground and adds weight. Or simply gravity, finally winning its long war against a weakened slope. A collapse could happen spontaneously. With no eruption. No warning from the deep magma chamber. Just the sound of the mountain coming apart. That is what the monitors may have detected this morning. Not a sign of eruption, but a sign of collapse. A gravity-driven Lahar. To the people in the valley below, the distinction is academic. The result is the same. A wall of mud. The USGS Cascades Volcano Observatory is one of the most sophisticated monitoring operations on the planet. They are not guessing. They have a network of seismometers listening for the unique signature of magma moving underground. They have GPS stations that can detect the ground swelling or deflating by millimeters, a sign of the volcano breathing. They have cameras watching the summit 24/7. They fly over the mountain, sampling gas emissions for changes in sulfur dioxide or carbon dioxide. Tells from the deep earth. And they have the acoustic flow monitors, the Lahar tripwires. The signal from this morning was not an earthquake swarm. The GP stations have not shown the kind of rapid inflation that would signal an impending eruption. The gas readings have been elevated, but within the range of normal fluctuation. What is new, what is alarming, is the combination. The subtle ground deformation on the west flank, detected by GPS over the last 3 weeks, and now the acoustic signal of a potential internal failure in the exact same location. The data points are corroborating each other. The mountain is talking through different instruments, and it is saying the same thing. A specific part of it is becoming unstable. I know. I'm mentioning it again. It feels like an ad, but our subscriber numbers are how we keep the lights on for these deep dives. It's just the reality of YouTube. If you have not yet, and you have watched this far, please take 1 second and hit subscribe. It makes a monumental difference to our ability to do this work. Thank you. Scientists like Seth Moran at the CIVO are relentlessly pragmatic. They do not use words like imminent lightly, but they talk in probabilities. They talk about trajectories. The trajectory of data from Rainier's west flank is pointing toward increasing instability. It is a slow motion failure that could accelerate at any moment. The 160 million cubic meter estimate is a snapshot. It could be larger. That volume of material is enough to create a lahar that would reach the town of Ording and bury large parts of it under 10 to 20 feet of mud. It would continue downstream, inundating parts of Puyallup and Sumner. It would choke the Puyallup River, causing catastrophic flooding and severing transportation corridors for weeks, months, or even years. The economic damage would be in the billions. The human cost is what emergency planners are desperately trying to prevent. The evacuation plan itself is a marvel of logistics and a terrifying gamble. The idea is to move tens of thousands of people vertically, not horizontally. Trying to get everyone out of the valley on roads is a non-starter. The roads would be gridlocked in minutes. The only survivable path is up. So the plan is for people to abandon their cars, their homes, their possessions, and run. Run for the valley walls. In Ording, they have the Lahar Walk. In Puyallup and Sumner, they have designated evacuation routes leading to neighborhoods on the surrounding plateaus. But the scale is daunting. Imagine the entire population of a small city trying to get up a handful of hills at the same time, in the middle of the night, with a roaring sound chasing them from behind. This is the reality planners have to work with. They've built vertical evacuation structures in some places, like a new elementary school in Puyallup, built with a reinforced rooftop designed to serve as a high ground of last resort. It's an admission that not everyone will make it out. It is a lifeboat built into a school. Think about that. The solution is not to move the town. The solution is to build a fortified roof and hope it is high enough. The problem is compounded by a psychological phenomenon known as normalcy bias. When faced with a disaster warning, many people hesitate. They look outside. The sky is clear. The birds are singing. It is difficult to accept that a threat you cannot see is minutes away. They might try to gather belongings. They might try to find their pets. They might wait for a second opinion. Every second of hesitation is a second the Lahar gets closer. In a 40-minute window, there is no time for normalcy bias. The only correct response is immediate, unquestioning flight. Bill Loki, an emergency management expert who has worked on the Rainier plan for years, has stated the challenge in the starkest terms imaginable. The physics of the hazard are unforgiving. Human behavior is the variable. And here is where the story gets even more complicated. The threat is not static. Climate change is acting as an accelerant. As global temperatures rise, the glaciers on Mount Rainier are melting at an accelerating rate. This does two things. First, it exposes more of that weak, hydrothermally altered rock that was previously buttressed by ice. The glue holding the mountain together is literally melting away. Second, it increases the amount of meltwater available on the mountain, which can saturate the ground and trigger collapses, or add volume to any lahar that does occur. The volcano is becoming less stable as the climate becomes more unstable. The two systems are linked. A warmer planet means a more dangerous Mount Rainier. So you have a mountain with inherent structural weaknesses. You have a warming climate actively making those weaknesses worse. You have a new, documented signal of instability from a massive section of the summit. And you have over 150,000 people living in the direct path of a potential failure. Each of these facts alone is a crisis. Stacked together, they create a scenario that is almost without precedent in American history. A predictable, high-consequence natural disaster that has been studied, mapped, and planned for, but which still hinges on a 40-minute evacuation window and the perfect response of a terrified population. This is the final reminder, I promise. But if you have watched this entire report, you clearly care about this kind of in-depth storytelling. You see the value. Don't let the algorithm decide if you see our next investigation. Hit subscribe and take control of your feed. It means the world to us. The United States government lists Mount Rainier as one of the 18 very high-threat volcanoes in the country. But it is unique. No other American volcano has this specific combination of geologic instability and downstream population density. It is often called the most dangerous volcano in America. Not because it is the most likely to erupt, but because the consequences of it simply falling apart are so catastrophic. The alerts have gone out. The USGS has elevated its internal monitoring status. Emergency managers in Pierce County are reviewing their plans. But on the ground, for the people living in Puyallup or Ording, life continues. The mountain is on the horizon, as it always is. It is beautiful. It is silent. It is impossible to look at it and believe it could erase the ground you are standing on. But the machines buried in its soil are telling a different story. They are reporting that the silence is a lie, that the stillness is an illusion, and that the giant is stirring. What happens next is a question of physics and time. The 160 million cubic meters of rock and ice on the west flank are now a confirmed hazard. They could stabilize. The movement could stop. Or an earthquake, a rainstorm, or just gravity itself could provide the final push. The sirens will sound, the 40-minute clock will start, and the carefully practiced plans of an entire community will be tested against a force that does not negotiate. The legacy of our morrow is a reminder that warnings are not the same as safety. Knowing the danger is not the same as surviving it. The final, terrible unknown is not what the mountain will do. We know what the mountain will do. The unknown is what people will do in the minutes they have left when they hear the sound of the world coming for them. Stand in the middle of Ording and look up. The mountain is right there. It doesn't look like a threat. It looks like a postcard. But the history is written in the ground beneath your feet. And the future is being recorded by a microphone.